Okay. Hello, everyone. My name is Justin Essery. I'm an associate professor of politics and international affairs here at Wake Forest University. Welcome to the International Methods Colloquium. The IMC is a periodic online seminar discussion on the application of quantitative statistical methodology to the social sciences, sponsored by Wake Forest University and previously sponsored by Rice University and the National Science Foundation. This week's speaker is Michelle Torres. She's a visiting scholar and starting next year, assistant professor of political science at Rice University. And in fact, she's currently in my old office. So I was joking with her that we should set it up so she gives the introduction script and I give a talk. But we'll just go ahead and do it this way. Her talk is entitled "Give Me the Full Picture: Using Computer Vision to Understand Visual Frames and Political Communication." Michelle's talk is going to last between 30 and 40 minutes, after which point we will take questions from the audience. You can ask a question using the Zoom Q&A button that appears at the bottom of the webinar window. And you can ask a question at any time during the talk, but all questions will be held until the end of the presentation unless it's really something clarifying and I really need to break in. But otherwise, we'll hold all the questions till the end. A link to Michelle's paper and her slideshow will be available in the Zoom webinar chat window so that you may refer to it throughout the presentation. And I will post those links right after Michelle gets started with her talk. Now I'd like to welcome Michelle Torres to the IMC. Michelle, welcome.
Thank you. Thank you so much, Justin. And thank you everyone for being here, for tuning in. Thank you, Justin, for the opportunity of presenting my work. I am really excited about it. And hopefully it will be helpful for some of you. So please let me know if you have any comments or questions. Today, I'm going to talk a lot about images and pictures, and more specifically about the way in which we can use computer visual tools to extract information from these images. I am interested in identifying relevant political components of these images in an attempt to include visual content to answer and analyze political and social science related questions. And throughout this talk, I'm going to focus on the substantive root and core of this project, which is the Black Lives Matter movement. So to give you an idea of the background, I will start by giving you an idea of the background and motivation of this project. And I'm going to show you these headlines. They were published in newspapers in the US in May 3rd, 1963. And they're talking about these protests that happened in Birmingham, Alabama, in the context of the civil rights movement. If we read some of them, hundreds held in racial show, nearly 700 arrested, we get some information about what happened in these events. Apparently, there was some tension, there were some arrests, but we don't get much more than that. Actually, if we go back to the actual articles and read the full text, some of them are saying that the protests were very peaceful and that beyond the arrest, there were not a lot of eventful things to report. However, this is a picture that the New York Times published in its main cover when talking about this protest. And the picture is telling us a completely different story from what we can read in those headlines. This is a very violent depiction of a dog biting a 17-year-old teenager, apparently under the command of the police and without any instigation. I know that there's an alternative story to this picture, but I want you to focus on the feelings and emotions that it triggers. There are these feelings of disgust and unfairness, and I think it's very important that it really puts under the spotlight the main concerns and demands of the civil rights movement, which was discrimination and violence against African Americans. This picture is supposed to be a very important driver of policy change in the US because it raised international awareness about what was happening in America in a moment where the US was trying to win hearts and minds abroad. And it also mobilized public opinion in the US that eventually pushed for a policy change with respect to the demands of the civil rights movement. So a picture having a huge effect in the political dynamics that we see, but the effect of these pictures is not limited to these impactful and dramatic scenes. We can also have something as positive and nice in this picture that Barack Obama tweeted right after the nationalist protest in Charlottesville, paired with a quote from Nelson Mandela saying that no human being is born hating another human being on the basis of skin color, religion, or background. So a very, very powerful and positive message about union portrayed in this picture, while also portraying the charismatic personality of the main actor there. The main takeaway from these images is that they can help us to tell a story, and they can help us to frame a story. And these visual frames are critical to understanding media communication. First of all, images are very powerful drivers of emotions. We process and we understand images even in unconscious ways. And these emotions are going to affect cognitive processes that in turn shape attitudes and opinions. Further, image processing is way easier than the processing of other sources like text because it requires less skills and sophistication like literacy. But for me, something really important is that images convey information that goes beyond language. Again, they can tell us, they can help us to tell different stories and frame these stories. And just to be completely clear, what I mean when I'm saying this visual frame is visuals that an actor uses to relay information and that reveals what she wants you to see, what she considers relevant of a topic at hand. So how do these visual frames operate in the real world? Now I'm going to show you 4 different newspaper covers. They were published in November 25th of 2014, right after Darren Wilson, the police officer that shot Michael Brown dead in Ferguson, Missouri, was acquitted from any charge. The interesting thing that all of these newspaper covers share is that they are using exactly the same text taken from a newswire source, the Associated Press. The 2 different things between each of them are the title of the newspaper article and the picture. So in this case, for example, we see Michael Brown's family in a very emotional state right after hearing the decision of the grand jury. Here we start seeing a little bit more of tension in the environment with a heavy presence of the police, heavily armed, and the protesters. Here we see the protesters already engaging in a violent activity against the police. And finally, here we see absolute chaos. So definitely the culmination of a very violent night. So 4 different ways of telling 4 different stories or 4 different perspectives from the same story, even after giving the exact same facts through text. So these variants and these multiple frames that we can find of the same story is what motivates 2 of my main questions in this project, which are how can we identify relevant political components or relevant political frames in images, and how are these frames related to political factors that we care about, like ideology. So I'm going to start with the first question. And to answer this question, I think it's really important to understand the challenges that we face when we are trying to analyze visual content. First of all, we're bombarded by a huge amount of images and pictures. So coding is really complicated and can go really slow. But suppose that you have an army of RAs, you recruit them, then you face the challenge that it is really hard to define and standardize proper coding schemes for this visual content. But again, you manage to do it, then you will face the problem that coding, especially of images, is very sensitive to coder subjectivity and cognitive filters. Again, because the processing of images occurs even in a very unconscious level. But you might read these challenges and say, wait, they look a lot like the challenges that we face when we are doing text analysis, and somehow in that area, we have managed to overcome them. So this motivates the question of, can we do the same we do with text, but now with images? And my answer is yes. For example, we can emulate the very popular bag of words in text analysis with a bag of visual words regarding images. And the bag of visual words is a tool that I am borrowing and importing from computer science, and that has very intuitive steps. One, we need to identify key points in the images we are trying to analyze. We're going to extract the features from these key points in a way of conceptualizing or measuring something from the images. And then we're going to create a visual codebook. This is because, unlike text, we don't have specific tokens with a specific meaning attached to them, like sentences or words. So that's the reason why we need to create a visual codebook. And finally, we're going to build an image visual word matrix that we can then feed to supervised or unsupervised classifiers. So I'm going to start with the identification of key points. And this step is really straightforward. The idea is just to identify salient regions, edges, corners, blobs, based on pixel intensity changes. Why are we doing this? The edges and the corners and these salient regions are going to give us some information about what kind of objects we can find in a particular image. And these objects, the occurrence and existence of these objects also gives us information about what kind of message the image is trying to portray, about its general content. So there are multiple ways and multiple detectors, but for the purpose of this project, I am using a fast Hessian, which has the nice properties of being fast and scale invariant. The idea is that we identify the key points, and if we plot them, it will look like this. And as you can see, the key points are definitely aligning along the edges and salient regions of the picture, so definitely highlighting the things that pop up from this image. Then we need to extract the features from each of these points, basically to condense and quantify this information. And again, there are multiple ways of doing it, multiple descriptors of these key points, but for this project, I am using the root sift, which is an extension of the scale invariant feature transformation, a very popular descriptor in computer science. What I mean, or the way that I am understanding a feature in an image or a feature of a key point, is the change in pixel intensity in grayscale images. And we're going to measure this pixel intensity change with the use of gradient magnitudes and orientations. I'm going to go through a lot of detail for this step. So suppose that we have our image, we identify the key points here, and I'm going to focus on these little key points surrounded by the red square. We're going to take this key point and we're going to draw a neighborhood around this key point, more specifically a 16 times 16 pixel neighborhood around it. And then we're going to overlay a grid of 16 cells of size 4 times 4 pixels, denoted here by the pink grid. In each of these cells, we are going to be interested in computing how the pixels in the cell are changing along the X and Y axis. Basically, how the value of the pixel is changing in vertical and horizontal directions. And we're going to summarize this or represent this with gradients, which is basically just a vector indicating the direction in which the pixel intensity is changing, in this case from black to white, for example, and that's the reason why they are pointing down. And the length of these vectors is going to be the magnitude of this change. The idea is that we're going to build a histogram of these vectors. The x-axis is the multiple directions that the vector can take, binned into 8 bins. And then the density is going to be weighted by the magnitude, the length of these vectors, and then the distance to the key point. So these cells are going to be weighted higher than the cells in the outer skirt because they are further from the key point, which is the real point of interest. So at the end, in summary, what we want is to compute these pixel intensity changes with our gradients. For each of the 16 cells, we're going to have 16 histograms representing those gradients. We're going to concatenate our histograms that at the end is just a very long vector. And at the end, each point will be represented with a vector with 128 elements corresponding to 8 bins per histogram times 16 cells. So now we need to create our visual codebook. And again, this is a very important step because unlike text, we don't have these words or these sentences, n-grams that will help us to understand the meaning of a text. How are we going to do this? Well, suppose that you have all the images here, you detect your key points, you extract the features and map them into your highly dimensional space. And then what we're going to do is do a clustering. And we're going to take the centroid of each cluster, and each of these centroids is going to represent a visual word. Why are we doing this? Why are we clustering instead of taking all the features that we extracted from the key points? Well, the reason is that imagine if I ask you to take a picture of your face and send it to me, and then I grab all of these pictures and start the bag of visual words process, we're going to detect that some points are around the nose or around the eyes. But it's going to be really, really hard to find 2 identical noses. Even for the same person, the nose might be different in one picture to the other because of lighting, the angle in which the picture was taken, etc. So the idea of clustering and taking the centroid is taking an average of the concept of a nose and represent it with that average. That's the reason why we're doing this clustering. And at the end, that centroid is representing the means. The centroid is representing the mean of the feature vectors. But intuitively and graphically, this is in reality what a visual word is a cluster of mini patches. So this visual word, for example, has clusters of mini patches of large crowds or conglomerations of people. This visual word has little pieces of signs, which is basically like these light white backgrounds with contrasting letters on top. And this visual word has these clusters with dark backgrounds and body faces, body parts, and close-up frames of the images. So finally, we need to build our image visual word matrix. And the idea here is to have something very similar to the document term matrix in text. I know that you probably know what a document term is, but here is a refresher. So in the rows, we have the texts. In the columns, we have the words that appear in each of these rows. And then we're going to count the number of times that each word in the column appears in the row. So in this case, black is appearing 1 time here. Protest is appearing 2 times in this text. So the idea is to do exactly the same thing, but now have the images in our rows and the visual words that we built in the previous step in our columns, and again, count the number of times that these visual words are appearing in each of the pictures. The counting is going to be slightly trickier than counting just raw words in text. And for images, we need to do the following. We have our image, we then estimate the key points and focus on this big key point here. We're going to extract the feature vector associated with this key point. And then we're going to take the distance between this key point and all the centroids in our vocabulary or the visual words. And at the end, we're going to keep the one with the closest centroid, in this case, word 2, and we're going to say that this image contains one word 2. That's how we are going to do the count. So now I explained how these things works in a very mechanical way, but you might ask me, well, is this actually working? And are you able to identify more than just chairs in an image? Things that we actually, as political scientists and as social scientists, things that we care about. And to try to answer that question, I'm going to validate the bag of visual words in a very unorthodox way. The objective would be to identify political components in the data generation process of the images. And to do so, I'm going to run a structural topic model to identify underlying topics in the images. The validation consists on checking whether these topics are definitely giving us some relevant political information that we care about, like the attendance of the protest, the mood, whether there is like the presence of the police, etc. So for this validation process, I built a bag of visual words from 15,000 pictures from Getty with the label Black Lives Matter Movement Protest. The idea of using Getty is that because we have multiple pictures for one protest, I am assuming that it's getting the full picture of what happened there. Like there might have been multiple photographers deciding to focus on different parts of the protest, so we have a more complete idea of how the protest looked like. I'm building a vocabulary with 2,000 words. Remember, 2,000 means 2,000 clusters. And I'm selecting 12 topics for this particular STM with 2 prevalent covariates, photographer and date. Photographer to account for the ideology of the person generating the image, and date to account for the particular characteristics of a protest that are definitely going to influence the topics and the things that you see in them. So I'm going to show you 3 out of the 3 of the most frequent and exclusive visual words per topic. I manually label the topics based on the analysis of what kind of visual words I could see in each of the topics, and I'm going to show you 3 of them. So topic 1, I label it large crowds because the most frequent and exclusive words for this topic are definitely showing these visual words with mini patches of large crowds and large groups of people. For topic 2, I label it signs because, as you can see, the visual words are definitely having, again, this pattern of white background with contrasting letters on top. And finally, for the topic night activity, we are seeing these mini patches with dark backgrounds and then sparkles or splashes of light. And also very interesting, some pieces of uniforms, dark uniforms from police and army in the protest. So next, I'm going to show you the most representative images for each of these topics. And again, I'm just showing you three for sake of space and time. And you might say, okay, I think you cherry pick this. And yeah, I mildly cherry pick them, but I promise that they, like all the representative images that I took, look very similar. So in large crowds, for example, we're definitely seeing these large conglomerations and groups of people. For signs, again, we're seeing this overlay of letters. And for the night activity, we can see where the visual words were coming from, right? Like these dark backgrounds with some light on top, and again, the patches of police and army uniforms. And another way to validate this data is to see whether these topics are actually aligning with factual things we know about the protest. And to do so, I'm going to use data from the Black Lives Matter movement protest collected by Eleframe and beautifully curated by Williamson, Trump, and Einstein, and I complemented it with some information collected from research assistants at WashU. I have two outcomes: the number of attendants in a given protest I, and the arrests in this protest. And my covariates are going to be the mean proportion of topic crowd and the mean proportion of topic night activity of the pictures in this particular protest I. And this is a very simple and normal regression. I just want to see whether the crowd's topic is aligning with the number of attendants, and the night activity topic is aligning with the number of arrests. And yes, I find a positive and reliable relationship between in these two models. Number of arrests is generally associated, or they are more likely to happen during the night. So we are definitely seeing this pattern of these two proportions aligning with things that we know about the protest. So here I want to do a small pause to say that this is by no means the only thing that exists there in political science trying to do this. There are amazing scholars doing the most interesting and amazing research. We have Chris Lucas doing a lot with videos in political campaigns, Francisco Cantú using pictures of ballots and tallies to detect a fraud in elections, and Bryce and Melissa doing things from social polarization to police interactions, Andreu, Nora, and Alex doing stuff with protests, and all of these with very interesting results and very interesting approaches. I think the thing that we all share is that we are convinced that images and audiovisual material is really important, and that should be included in our analysis of relevant political questions. The way in which their work differs a little bit from this approach can be better explained if I tell you a bit about the strengths and weaknesses of this particular method. And the strength of the bag of visual words is that it's very intuitive and very simple to follow. As you could see, the steps are really straightforward. So not only the intuition, but even the math is relatively easy to understand and to track throughout the process. Also, it's really computationally cheap. People ask me how much time did it take to process your 15,000 images, and I processed them in a normal Mac laptop, and it took 6 hours, the full process. So it's actually a very fast procedure. It's also ideal for exploratory analysis, regardless of what your ultimate objective and analysis is. I would always recommend this to really get to know your data and see like what topics are there. It's good to identify some flaws in the data or things that shouldn't be there. So it's a great first step to really get to know what you're working with. And probably the biggest strength is it's very useful without label data. So unlike a convolutional neural network that really requires training samples, here you can just run it and build this image visual word matrix and feed it to unsupervised. But of course, it also has some weaknesses. It's way less accurate than other powerful and more sophisticated methods like convolutional neural networks, especially with regards to predictive power. So you can still use these for supervised classifiers, but then you will need very large training samples. And this is not very particular. This also happens for CNNs, but still the accuracy is going to be a bit worse than if you use something like a neural net. And it's also very sensitive to certain parameters, and we don't have a very good idea of how to diagnose the effect of these parameters. So this is actually fertile ground for more research on this method. So now I'm going to show you the application and what can you do, for example, with these topics that you identify in the images, these political components. And I'm going to focus on a particular frame. I know that there are multiple dimensions in a protest that you can focus on, but I'm going to focus on the frame and on the mood and environment of a particular movement. So basically, for example, this picture happening in the middle of the night with some tension in the environment, the police, probably a less inviting environment than this one here happening in the middle of the day, very bright, open space, very colorful. So how these things actually can shape important factors related to the social movement. And this is relevant because the literature in social movements and political geography really emphasize the importance of place and context in shaping protest actions, for mobilization, for raising support, for impact and communication with authorities. And in this case, for example, night is considered a politically dangerous and impractical time space. I know that night is a time of the day, but because of the characteristics like light conditions, it also shapes the environment in which things happen. That's the reason why it's considered a time space. And it's impractical because it affects basic stuff like logistics. Buses are not going to run at a certain point. And it's associated with these feelings of vulnerability and the idea that crime happens during the night. So this is a time space that is very likely, for example, to discourage mobilization and attendance of protests. And who is more likely to depict protests as negative or has incentives to discourage mobilization? The literature also says that conservatives are going to be less likely to support or to promote the idea of protest because protests do not align with principles typically considered conservative: preservation of the status quo, law and order, and patriotism. So my expectation is that more conservative newspapers or news media outlets are going to depict protests as more dangerous and risky, and they are going to do so by a higher proportion or a higher and more intense use of night activity. And to test this expectation, from a Facebook post of top 100 US newspapers. What I did is I went to the newsfeed of each of these newspapers and I collected all the posts mentioning Black Lives Matter or Ferguson protest. At the end, I ended up only with 221 images. That was my first surprising result. A lot of these newspapers were not talking at all about this, but it was something interesting to notice. With these images, I built an image visual word matrix based on the codebook that I generated from Getty Images in the step above. And again, I ran a structural topic model with 12 topics, and now I'm using ideological slant as a prevalence covariate. Ideological slant is this measure of ideology that Gensko and Shapiro developed for news outlets by comparing how they talk with the way that Republicans and Democrats talk in Congress to develop this measure. Some of the topics I identified: crowds, newspaper covers, because sometimes they just put in Facebook the cover of what they were publishing that day, scenes, individuals, and night activity. And again, I'm going to focus on night activity as a potential frame of the mood and environment of the protest. So here in this plot, what you can see in the x-axis are the newspapers in my sample, and the y-axis, the mean proportion of the night activity topic I detected per newspaper. Here I'm highlighting a few of them. It's a top 10 plus the St. Louis Post set. And as we can see, there's a lot of variance in the way that these newspapers are using the topic night activity in the images they are publishing about the Black Lives Matter movement. So the Fresno Bee has almost no proportion of night activity in their pool of images, while the Dayton Daily News has a very high proportion. And you can say, well, this is kind of like cheating because it might just be that they are covering different protests, and you are totally right. So we can disaggregate these observations In the x-axis, there's time, and the red lines, these red dash lines, are showing important events in the Black Lives Matter movement timeline, like for example the Dallas shooting or Wilson's indictment. And we see that even for the exact same day, the proportion of these topics are used in very different ways by these news outlets. So we want to know if this variance is associated with something like ideology, and I found that yes, there's a positive and reliable relationship between ideological slant and the use of the proportion topic night activity, indicating that the more conservative the newspaper is, the higher the likelihood or the higher the proportion of using topic night activity in the image they use to inform about the Black Lives Matter movement. So just to conclude, images are powerful and abundant elemental frames. And this particular approach, the bag of visual words, can be used to detect things that we care about and a way of quantifying these visual frames. And it's ideal to feed supervised and unsupervised classifiers and methods. The measurement and analysis of these components is crucial to have a better understanding of political communication and ethical information. Again, we're seeing these almost like natural experiments in the real world where they are like changing the picture but keeping the facts stable or equal. And things that we can do and things I'm working on currently, one is like the substantive use of the bag of visual words. So not only to analyze what the image says, but also to include what the text says and how are they interacting or complementing or contradicting each other. The identification of other frames, not only mood, but size or activities, and also to compare the sources of images that we are analyzing. What is social media saying, the protesters tweeting from the protest, versus what regular media decides to publish, for example. And regarding the methodological angles of this particular approach, I think it would be interesting to add color channels, because color also gives you information about the type of picture and is very important in political marketing, for example. As I said before, we need more validation, more diagnosis to see how the parameters that we're using to tune the bag of visual words and the decisions that we're making are appropriate. It's very surprising to see that there are not a lot of things that written about this. So it's something that I definitely want to work on, and also to have an extension to videos. So thank you very much, and I am really looking forward to your comments and questions.
Okay. Thanks, Michelle, for the presentation. At this point, Michelle Torres is available to take questions from the audience. You can ask a question using the Zoom Q&A button that appears at the bottom of the webinar window. And a question came in during the talk, which I think is appropriate to something you said at the very end. You mentioned the link between visual data and social media. And Christina Gahn asked, do you know of some studies or researchers which tried a similar approach using pictures of social media content by parties or politicians?
I actually don't. So I know that a few working papers, Jason Anastasopoulos is working on them on how to detect ideology, for example, or partisanship from the images that politicians post in their Facebook accounts. But I haven't seen any comparison, for example, to what they would publish on Twitter or on other sources like their homepages, for example. And I think that would be like something really interesting and a really good application of not only this method, but for example, the CNN or other visual analysis tools to really have this comparison of how people are portraying themselves with pictures in different environments. But apart from that, I don't know if there are more people doing it. It's a very small group doing it, at least in political science. So this is the best I can remember right now.
So she actually added that she's especially interested in using this approach in election campaigns. Mm-hmm. I assume. I mean, I'm guessing a bit, but I assume it would have one question I would be interested in about campaigns is the extent to which campaigns use different visual vocabularies. What do they motivate their supporters using different appeals, different types of appeals that are represented in different images? Anything like that you know about?
No, 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 no. I don't think anyone is doing it. And I actually talked to to my co-authors, Francisco, about doing it for the Mexican case, because we were definitely seeing some differences also in the way that media was showing these images, not only coming from the campaign. I actually have a fun example. Again, like just talking about potential ideas. When I was talking to a journalist about this, she mentioned that she was in charge of writing some reports for the when the presidential campaign was happening, and you could tell that sometimes the journalists were posting pictures where Trump looked really bad, and and it was like a small revenge for them because it was not altering the facts of what they were saying, or there was no actual opinion with text, but the image was definitely sending another message. So we just talk about it of like how interesting is this in the way that you can use these images to send underlying messages, but I haven't seen anyone doing it in a systematical way. So yeah, that would be super interesting for her to do it.
So going off of the thing you just said about embarrassing pictures of the president, you can imagine choosing a photo where he looks presidential, sort of in command and authority, or you can pick the photo where he's got that piece of toilet paper stuck to his shoe and he's getting into the Air Force One, or remember the one where he just kind of drops the umbrella like for no reason. So in other words, you can choose pictures that are more or less embarrassing. Would it be possible to recover the embarrassingness of a photo from your technique, or would you have to do something different?
It's possible. Like technically, it's completely possible. But as much as I love these methods, and for example, I'm a big fan of CNNs too. I think that we also need
CNN
to be.
stands for convolutional neural network, by the way,
Yes,
in case.
sorry.
Yeah.
Yes, convolutional neural networks. I think we need to be very careful on what kind of things we want to measure, and always ask the question: do you think there would be a lot of like high levels of agreement among human coders about what's embarrassing or not? And some people, I'm pretty sure a strong Trump supporter will tell you that the umbrella picture is not embarrassing. It's just like showing that he doesn't care about trivial things. He just is focused on the big things or in the big picture of other more serious stuff, right? So if there's no way of really like tapping into the concept, if the concept is too ambiguous, I think the model or this technique is going to fail, not in the sense of recovering the patches and the feature vectors. It's gonna fail in the training and testing process. Like, are you really detecting such an ambiguous and abstract concept that it's highly dependent on your perception of what embarrassing is? So we just need to be careful on what, like, the scope of these methods is limited in that sense. Like if it's a very ambiguous and abstract concept, then we need to go back and redefine it.
So Laura Nelson asks a very good question. Do you have a code repository to replicate, and I assume the more interesting thing would be to apply to another problem, the methods that you implemented here? She said it might be in the paper, but she hasn't looked at that yet.
No, it's not in the paper, so it's not there. I am working on like really refining the functions and everything, because now the code is a bit messy. But of course, I'm gonna share it once it shouldn't be too long. I'm definitely gonna share it, and I'm gonna put it in a public repository in GitHub. In a way, also, like, I'm also working on tuning it, so the input is just very, very simple stuff like the directory to your images and other few things that you need to tune, but to make it as general as possible. So shoot me an email, and I will let you know as soon as I have it ready.
Is the code written in R or Python or something else?
It's Python. I'm using basically OpenCV, that stands for Open Computer Vision. It used to be really hard, actually, for me. Always the hardest part was to compile it from source, but now it's also in pip install, so it's perfect. So it's in Python. There are a few translations into R, but all the packages in Python, and then the process of learning and testing and everything it's better in Python too. So that's why I stuck to it.
Would it be possible to create an R package, or would there be any advantage to doing that?
I think some functions are just can't handle them. But it's something that I have in mind. I am a heavy R user and I love R, so I would love to have something like that. The thing is that Python is much better also at handling big data. So, and this is like, even if you have very few images, this is the definition of big data. You have a lot of information. So it's always better. I think that's the reason why actually nobody has ventured to create something really big in R. Again, there are some packages, but nothing that really includes everything that you can find in Python.
So one area of research that definitely has to do with computer vision, but definitely doesn't have to do with political science, is the self-driving car, right? So they have these projects that are designed to use input from cameras and from LiDAR and whatever, and then translate that into some sort of behavioral response from the car itself. And my question is, now obviously I'm not that interested in like the driving part, but I'm interested in the seeing part. Like, are they able to identify, it seems like they would have to be able to identify things like stop signs, right? And, you know, margins of the road, or like, what do you call them? Shoulders, indicators, turn signals, stuff like that. Which would mean you could actually get, in principle, a clean identification of certain objects or behaviors out of the system. Whereas in your system, you get classifications, but they're essentially clusters, right? They're not, it's not, until a human goes in and looks at them, it's unclear what they are. So I don't know how much you know about what they're doing in this other sort of visual processing arena, but I'd like to know if they're doing the same thing, if they're doing something different, and what the advantages and disadvantages of using that method versus using your method are. I know you covered this in the strengths and weaknesses slide, but I'm particularly curious to sort of get deeper into that.
Yeah, no, absolutely. And I actually think that part in computer vision is one of the most developed and most advanced, which is object detection. So there are very good data sets with a lot of information about signs and dogs and flowers and like how to identify these objects. And that's pretty big because I think there's a lot of interest in like an engine, for example, to search for images, like the Google image where you put an image and tries to find something similar, or to detect objects. The application is to detect faces, for example, in Facebook and things like that. So that part is very advanced. I actually started like the whole project with the idea of doing something similar to detect weapons and to detect
like Molotov cocktail.
Fire. Yes, yeah, exactly, and detect stuff like that. It was hard because I had to include a lot of things, like really think about all the things that I could possibly think were associated with, let's say, a violent protest. And I'm pretty sure that I was going to miss some things, and some of them are, like the weapon might not be super obvious, for example, but there might be a police in that moment arresting someone. So then I will have to look for the action of arresting someone instead of just a weapon or just fire. So I think at the end, this construction of to really work with the construction of this concept was much harder than seeing, okay, what kind of patterns you can identify that seem to be associated with a latent measure. So I think this worked really well because it allowed me to identify even things that I wasn't looking for. And I know that that's not gonna go very well with political scientists because we generally want the hypothesis to test in advance, but I think it definitely helps you to learn more about your data and more about the things that you have at hand. And especially because you can't go through 15,000 images one by one in a very in a lot of detail, right? So if this is giving some information about your overall sample, and then you can identify some red points somehow, then I think it was a very interesting approach to discover stuff from the data.
So Laura Nelson asked, so you may have heard of GPU or Nvidia CUDA implementation. Do you have to do something like that in order to do this, or is this all on basic CPU processing?
I love that question. No, this is why this approach is my favorite, because it, unlike convolutional neural networks and some other stuff that really requires more power. Here, you don't need any of that. I mean, you could to make it faster, but it's very fast in general, so you don't need a lot of power, and you don't you don't need a cluster. What I like about this method is that it's very accessible for people that want to learn it. It's actually accessible, not only to understand it, but to apply it to their particular stuff. So once we talk and I send you the code, then I think you can be able to run it without any other crazy GPUs or cluster or anything.
Mm-hmm. And on the substantive side, are you able to identify things like the gender of people in the image, the age, or race, or something else?
For this one, no. Well, that wasn't my intention. I mean, I'm pretty sure that, for example, if I put a lot of images of kids and people, and then I tune the number of clusters and everything, I will be able to get a cluster and topics really giving me an idea of how many kids and how many adults are in the picture, and similar with pictures of women and men. But at least this project is no focused on that, and it's also hard, especially for example race. Race is something that it's very trendy as well, and you can see it as an application, but it's very hard because then you need to detect like color, like all the decisions are based on color, but the lighting conditions can affect that, the definition of the image, things like that are not per se associated with race, but are definitely affecting the final classification. So that one is a bit harder. And at least here, I'm definitely not focusing on it.
Mm-hmm. I'm going to ask a question you might not know the answer to, but I'm just interested. People see. That's a thing we do. You could hire human coders to basically do a similar thing to what you're doing, and they might even be better at it. It's just expensive to get so many people to process so many images. It reminds me of World War II, where computers were people and they just had rooms full of them, doing math problems all day. It's like that, right? Do you know much about the biology of how it is that we see and how it's related to these techniques that we're using in computation? Is it totally different? Are they related in any way?
Actually, I think I have part of an answer to that question. So for example, for convolutional neural networks, the full objective of the CNN is to try to replicate the process in which the brain digests visual content and translate it into a concept. But I know, for example, a lot of people, including one of my advisors, is that no, it's not true. Like, not even we actually don't even know really how the brain works, like in the full extent. So then, really trying to replicate the process with a computer can be really tricky, or it's an overstatement. But actually, the idea, I actually think it has a point. Like the idea of a convolutional neural network having different layers, just as the brain, like the cortex, and each layer in charge of defining or identifying particular things. So the first layer identifies the silhouette and the change of color. The second one identifies the particular edges. The third one identifies the texture, like things like that. So at the end, it creates a full picture of what you have, and then goes back to your memory and says, oh, yes, I've seen this when I was little. This is a cat, or something like that. So these methods are trying to replicate a bit of what's happening in the process. Of course, it's so complicated because visual content is operating in different layers. But I think they are all inspired by that, which I think it's very fascinating, like the idea of trying to replicate it.
You talked about, this is a question from the audience, from Christina Gunn. You talked about color and only showed black and white pictures. Are the pictures like that in the first place, or do you have to recolor them? Is this method not using color yet? And would it be hard to implement also the use of red, blue, green, and so on?
So everything now that I showed you is based on grayscale images. And yeah, they were originally colored, but I transformed them to grayscale images. And then the whole process is with this. I definitely want to add color. The problem is, I think, for example, I started working on it and I thought I was really, really close. But then it's hard to attach to each key point like the measure of color. So now what I have in mind is, for example, to take the key point, take the neighborhood, and have a color histogram or a color distribution using the RGB channels, and then try to add it as an extension of the feature vector, and those are as more variables. I did a test with that, and it wasn't giving me much more than or it wasn't that different from what I had only with the pixel intensity change. And my impression is that this color distribution wasn't properly capturing the colors. It wasn't about, it's not about having red, green, and blue separated, but about the combination. So I think I need to think more about it, and I want to talk to computer scientists to help me with that, because so far, yes, the bag of visual words as we know it is just with grayscale. I read a paper trying to incorporate colors, but it was like a different process. But I've never seen an application with images in color.
Laura Nelson asked, do you know anyone who has tried to translate word embedding models to images to take into account the context of a visual word?
No. And it's interesting because I don't think this is used that much. Definitely not in political science or in some of the social science pieces that I've read in psychology or sociology, and probably in computer vision, maybe. But this is the idea, right? Like, this is just going to give you the image visual word matrix, but then you can do a lot of stuff, and you can like start thinking about how to, instead of building just this count of words, then building n-grams, or then building paste of clusters or things like that to account for the context in which the word is. There's another bag of visual words, but it's called the bag of pyramidal words, which, for example, takes into account the position where the word is. So a bit like this contextual thing. And you can do that, for example, but like a concrete application, I can't think of any so far.
Well, we're out of questions and pretty close to the end of the time, so I'm going to go ahead and thank Michelle Torres for being our presenter this week. I want to also note that her presentation will be posted to our website shortly after this broadcast if you'd like to share this presentation with a colleague or watch it again. I'd also like to advertise a talk next week. On February 8th, at the same time, we will host Marcel Neunhofer of the University of Mannheim for a talk entitled Flexible Multiple Imputation for Social Science Using Generative Adversarial Nets. Please see our website, www.methods-colloquium.com, to get more information about this talk. Michelle, thanks for giving a talk today.
Thank you so much, Justin. And thank you, everyone. And please let me know if you have questions. I'm happy to answer by email.
And hope to see everyone for next week's talk. See you later.